At 4.1, which is entitled Solving a Simple Equation. So we're actually getting into a little algebra with this chapter. One thing to remember about solving equations in general is that whatever you do to one side of the equation, you must do to the other. And this ensures that we have preserved equality. It preserves that, the quantity is still the same. So whatever you do to one side, you must do to both sides of an equation. Now we have a couple properties that will help us in solving simple equation. One is called the addition property of equality. And basically what that says is that, if I have something that I know is equal, then I can add the same quantity to both sides. And this also works for subtraction, because addition is nothing but subtracting a negative, is nothing but adding a negative number. So you can add the same quantity to both sides, or you can subtract the same quantity to both sides. Both of those are under the addition property of equality. The second property is the multiplication. And what that says is that if we know A equals B, then A times C equals B times C. I can multiply both sides by the same quantity, and the equality is preserved. In addition to that, you can divide both numbers by the same quantity. Division is nothing but multiplying by the reciprocal of a particular number. So we can multiply both sides by the same number, or divide both sides by the same number. Now, we have this procedure for solving equations. Let's read through that. Number one, if you have any fractions in the equation, then you need to get rid of those. How do we get rid of fractions? Well, you look at all of the denominators in the problem. You may only have one denominator, or you may have two or three. You look at all of the denominators and you find the common denominator. Okay? The common denominator is the least common multiple of all of the denominators you have listed. So you get a common denominator, and what you do is you multiply every single term on both sides of the equation by that common denominator. If you have truly done this, then you will have gotten rid of all the fractions in the problem. The second step tells us to use the distributive property to remove any grouping symbol. So if you have parentheses or brackets, use the distributive property to remove those. Number 3 says to combine like terms on each side of the equation. Okay, so you may have x's on the right hand side and x's on the left hand side. Combine everything. Step number 4 says to perform the same operations on both sides of the equation until you get x equal your result. Now, a lot of students ask, does it matter which side of the equation I choose to get x on? And it does not matter. It does not matter whether you choose to get x by itself on the left-hand side or x by itself on the right-hand side. You should get the same result. Number 5, it says check your solution by substituting into the original equation. Now we want to go to the original one, not one that we messed with, but the original one. Now step number 5 is not necessary, but it will help you, because if you check your solution and you don't get a true statement back, then that means maybe that's not really the solution. Maybe you've done something wrong. So it's a way of checking your work. So what we're going to do now is we're going to look at some equations. It says solve for x and then check your solution. We're going to check some of these solutions in the beginning, but for time's sake, we're not going to go through and check every single one. The first question we're going to look at is x minus 4 equals 7. Now, the goal here. Remember, our goal is to get x on one side by itself to get x on one side of the equal sign by itself. And to do that, we're going to have to reverse some things that are being done. Here we have x minus 4 equals 7. Well, I have a minus 4 on that left-hand side. And the only way I can get rid of it is to do the opposite. So instead of subtracting 4, I'm going to go through and I'm going to add 4 to both sides. So x will be, because negative 4 minus 4 is 0, x is going to be 11. Now, is this really my solution? Well, let's check. We go back to our original equation. We put in 11 for x. 11 minus 4 equals 7. Is that a true statement? Well, 11 minus 4 is 7. 7 equals 7. Whenever you get a true statement back, then the solution checks. It is the solution. Okay, that's what they mean by check your solution. Go back into the original equation, substituting what you found for x in there, and seeing if you get a true statement. Number 6, we have 3x equals 21. Well, we're multiplying by 3. I need to do the opposite and divide by 3. So 3x over 3 is just x. X equals 7. Does it check? Three times 7 equals 21. Yes, 21 equals 21. So it checks, and x equals 7 is our solution. The next one, number 10, we have x divided by 5 equals 8. Equals negative 8. So we're dividing by 5. We need to do the opposite operation and multiply both sides by 5. When we do that, our 5's cancel. We have x, not 5, x equals negative 40. And if we check, sometimes we can do a mental check. Put x in there. Negative 40 over 5 is negative 8. So that is our solution. Now, number 14 brings into play where we may have to use more than one step to get to the solution. In the previous problems, we could solve them just by doing one operation. We have 3x minus 20 equals 15. The first thing you want to do is to get the expression involving x on one side by itself. So I do the opposite and I subtract 20 from both sides. I have 3x equals negative 15. And then since I have the term involving x on one side by itself, now I need to get just plain old x or 1x over there by itself. I divide by 3. X is negative 5. And if you check, 3 times negative 5 is negative 15. Negative 15 plus 20 is positive 5. So it checks. Let's look at number 16. Number 16 is very similar to number 14. We need to get the term involving x on one side by itself. So instead of subtracting 2, we're going to add 2 to both sides. We have 3x equals 18. Then we can divide both sides by 3. X is 6. And we can check. 3 times 6 is 18. 18 minus 2 does equal 16. All right, number 18. Here they add a little bit something different in there. Now we have an x expression on the left hand side and the right hand side. And what we need to determine is, do we want to get our x's on the left-hand side or the right-hand side? Remember, a few minutes ago I said, you know what? It does not matter which side. Most people like to get the x's on whatever side will make the x's positive. We have 5 minus x equals 8x minus 13. So I have a negative x here on this left-hand side. If I want to get rid of that, I can add x to both sides. So what this becomes is 5 equals 9x minus 13. I chose to add x to both sides so I can get all my x's on the right hand side, and notice that those x's are positive. I like to deal with positive numbers if I can. Okay. Now I need to get this 9x on this right hand side by itself. So I need to add 13 to both sides. So 5 plus 13 is 18. And we're left with 9x over there. So 18 equals 9x. Then I can divide both sides by 9. So x equals 2. X equals 2. Let's look at another one. Number 20 is very similar to what we just did. We have a negative 2x on the left-hand side. We have a positive 5x on the right-hand side. So I can add 2x to both sides. And I have 14 equals 7x plus 7. I need to get that 7x over there by itself, so let me subtract 7. 14 minus 7 is 7. On the right hand side, the 7 and the negative 7 cancel out, so we have 7x. And then I can divide by 7. X equals 1. X equals 1. All right. Now we have an expression or an equation involving a fraction. And if I'm not mistaken, this is the first one that we've had so far that involved a fraction. And remember, it said that if we have any fractions in our equation, then we need to get rid of them. So we look, 3 is the only denominator that we have. So that's going to be our common denominator. I need to multiply every term throughout this whole equation by 3. Every term. So here the 3's cancel. I have x equals 12 times 3 is 36 minus 3x. Okay. Now I need to choose which side do I want to get my x's on. Well, if I add 3x to both sides, then my x's will be positive. X plus 3x is 4x equals 36. These 3x's cancel. Divide by 4. X equals 9. X equals 9. Now, not only is it important that we, know how to solve equations that's given to us, but it's also important that we be able to translate an English statement to an algebraic statement. Now, later on in this chapter, we're going to be doing word problems, and in dealing with word problems, we're going to have to be able to take the words, put it as an algebraic expression, and then we're going to have to be able to solve. So what we're going to do now is to set up the equations from the given statements. 3 more than a number. So first of all, we need to let x be a number. 3 more than a number is x plus 3. Is equivalent to equals 11. 3 more than a number is 11. Number 40 says 6 more than twice a number. So for all these problems, this number that we're going to talk about, we're going to let x be this number. 6 more than twice a number. So we have twice a number is 2x plus 6 equals 4 times the number, so 4 times x. 2x plus 6 equals 4x. Now, I know you're saying 6 more than twice a number. I could have said 6 plus 2x, but if you're multiplying something by that number, you may, depends on how the problem is written, you may want to write it first. For example, when you're dealing with less than, it matters which expression comes first. Number 44 says 7 less than 6 times a number. So first of all, I need to get 6 times a number. And to get 7 less than that, then I need to subtract 7. Now notice, this is different than 7 minus 6x. 7 less than 6 times a number. So you got to get 6 times the number first and then take away 7. It equals the number less 14. The number less 14. So the number minus 14. Okay? So in these problems, we were also supposed to solve. So let's go back and solve. Here, x plus 3 equals 11. So we subtract 3 from both sides. X is 8. Here we have 2x plus 6 equals 4x. I'm going to go ahead and move 2x over by subtracting 2x. I have 6 equals 2x. Divide by 2. X equals 3. And then number 44, 6x minus 7 equals x minus 14. I'm going to go ahead and subtract x from both sides. So I'm going to have 5x minus 7 equals negative 14. And then I'm going to get this 5x over here on both sides by adding 7. So we have 5x equals negative 7. Divide by 5. We have x equals negative 7/5. And yes, it is possible for us to get, fractions back as an answer. In the previous problems, they all turned out to be integers or whole numbers or whatnot. But hey, sometimes it does not work that way. Now, if you notice, in all of the equations that we have just solved, we got one value back. We got a specific value back for x. And whenever you get a specific value or specific values, because some equations have more than one solution, then these are conditional equations. They are true for only those particular values of x that we found. Now we have two other types of equations. One is called an identity. An identity is true for any value of x that you put into that equation. A contradiction is an equation that is not true for any value of x. So we're going to look at the last problem that we're going to do in this section, number 46, and we're going to distinguish, the type of solution that we have with these two equations. And I'm going to add another equation to this. We're going to look at this as our first equation. This is our second equation. And the third equation we're going to look at is x plus 5 equals x plus 5. So we're going to call this part A, part B, and part C. Let's investigate part A. We have x plus 1 equals x minus 5. And we want to solve as normal. Let's try to get x on one side by itself. So when I subtract x from both sides, my x's go away on both sides, and I get 1 equals negative 5. Now we know that this is a false statement. So whenever you go to solve an equation, all your variables go away and you're left with a false statement. This is called a contradiction. That's a contradiction. Now part B, we have x plus 1 equals 5 minus x. Now, I'm going to go ahead and add x to both sides. That gets rid of those x's on the right hand side. I'm left with 5. Here on the left hand side, I have 2x plus 1. So I can subtract 1 from both sides to get my x term on one side by itself. And I can divide by 2. So x is 2. Here we got a specific value back. And this is a conditional. Equation. So we had a contradiction, we got a false statement. Conditional is where we actually get a specific answer back. And let's look at part C that we created up there. X plus 5 equals x plus 5. Now, certainly here we can look and say, okay, we have a true statement. But let's go ahead, because sometimes it may not be as easy as looking at them and telling. We subtract x from both sides. We have 5 equals 5. So our x's go away. This is a true statement. So that means no matter what value of x we put into there, we'll get a true statement back. This is an identity. This equation is an identity. All right. So we've covered simple equations. Simple equations.